Hello NSA student, this is Mr. Hinton with the Math Department. And one of the other big topics that is covered in week 22 is the special right triangles. Now special right triangles, there's two kinds, or these are two special right triangles. There is the 45, 45, 90 triangle. And that just means that one of the angles here is 45 degrees, and of course we have the 90-degree angle. And we've already shown and seen that the two acute angles of a right triangle are complementary. So often when you're given a 45, 45, 90 triangle, you won't be given both angles, you'll be given only one of those, and you'll have to recognize that this situation holds true. Now here's the relationship that exists in all 45, 45, 90 triangles. Because it's isosceles, meaning it has two congruent angles, it also has two congruent sides. So the legs of this right triangle are equal. So in a 45, 45, 90 triangle, the legs are equal. And that means if this side is 7, then this side is also 7. Okay? And the other thing that is true in all right triangles is that the hypotenuse is equal to the value of the leg times the square root of 2. So in this particular example that we're looking at, if both of the legs are 7, then the hypotenuse is going to be 7 times the square root of 2. All right? Now, oftentimes we'll have to do that relationship in reverse. So if we are given the hypotenuse, then to go from the hypotenuse back to one of the legs, so to go from a given hypotenuse to the value of one of the legs, instead of multiplying by the square root of 2, you're going to divide by the square root of 2. All right, so in a 45, 45, 90 triangle, we know these two things to always be true. The two legs are equal to each other, and hypotenuse is always going to be the value or the length of the leg times the square root of 2. So if we're going from hypotenuse back to the legs, then we would divide by the square root of 2 instead of multiplying by the square root of 2. All right, so that's the 45, 45, 90 triangle. And again, in your problems, you won't usually be given that both of the angles, you'll be given one angle or the other. Okay, so if you see a 45-degree angle, then you have to start thinking about the special cases and the special relationships between those sides. Now, the other special triangle, special right triangle, is the 30, 60, 90. And just like in the 45, 45, 90 triangle, most of your problems are only going to give you one of those angles. So they'll give you the 30-degree angle, or they'll give you the 60-degree angle, and then you have to kind of deduce that you're dealing with one of the special right triangles. There's three parts of the special right triangle. Okay, this 30, 60, 90 triangle has three parts. So of course we have the hypotenuse. The side that is opposite the 30-degree angle, we're going to call it the short leg. It's the short leg because it is opposite the 30-degree angle. And then the side that's opposite the 60-degree angle, we're going to call it the long leg of the triangle. Now, the relationships in the 30, 60, 90 are a little bit more complicated than they are in the 45, 45, 90 triangle. Obviously because it's not isosceles, but here they are. The short leg, I'm going to abbreviate that. The short leg is half of the hypotenuse. All right, so let's just say that the short leg was 3. Then that means the hypotenuse would have to be 6. So you multiply the short leg by 2 to get the hypotenuse, or if you're going in reverse, you're going to divide the hypotenuse by 2 to go back to the short leg. All right, now the other ratio, or the relationship there that exists, is that the long leg is the short leg times the square root of 3. Alright, so in this particular instance, since the short leg is 3, the long leg is 3 times the square root of 3. And that relationship is always going to exist in 30, 60, 90 triangles. Okay, now because this particular special triangle is a little bit more complicated to work with than the other, let's give ourselves another example to work with here. Let's suppose that we were given that the hypotenuse is 7. If the hypotenuse is 7, because this is a 30, 60, 90 triangle, this relationship always exists. The short leg is half of the hypotenuse. Short leg is half of the hypotenuse. That means half of 7 is 3.5. And again, the short leg is always the leg that's opposite the 30-degree angle, and the long leg is always the side that's opposite the 60-degree angle. And then the long leg is the short leg times the square root of 3, so this long leg would be 3.5 multiplied by the square root of 3. Okay? Now, when you're working with a 30, 60, 90 triangle, the key to doing this correctly is always find the short leg first. If the short leg is not given to you, that's what you have to find first. So if we're given the hypotenuse, to find the short leg, we are going to divide it by 2. And if we're given the long leg, instead of multiplying, we would divide by the square root of 3 to go back to that side. So that's how the ratios work in the 30, 60, 90 triangle. Thanks and have a great day.